Hello everyone, welcome back to another lecture on the course Python Fundamentals Building Blocks for Aspiring Developers. So in this one we will start with the fifth module and we will look at some other data structures. Just the second part we will look into a bit more detail. So this is our agenda for this module. We will look at different nested data structures. Then we'll have a look at the loops break statement, especially. We did have a look at that one, but we didn't perform that one, but it will make much more sense if we do it here. Then we will have a look at different comprehensions like list comprehensions, dictionary comprehensions. Then also we will have a look at tuple unpacking. So these are all of these things deal with lists, or you can say sequential data structures and nesting of those data structures. So let's begin. So let's start our day. So what is nesting? So nesting in Python basically refers to structures that contain other structures. For example, a nested data structure list could also have a list within itself, like first item of a list could be another list in itself. So this is nesting. We've already seen one small example in one of the previous lectures, but we will go into detail. So nesting can occur at any level or any depth. We can have like 3 or 4 different nestings, like one list, and there's a list in that list, and another list, and so on. So it could be as many level deeper as we want. And by this, it allows us to create complex and hierarchical data structures. And net data structures, nested data structures can be list of lists, dictionary of dictionaries, set of sets, or any combination of these collections. There is no restriction really. So this is one of the example of list of lists. So here, if you look at the first example, each element is itself a list. So if you look at the blue underline, you see that is one list, and the yellow underline is supposed to be the first element of the outer list, but it is a list in itself. So this is like how nesting lists look like. And if we are to now access the elements in the list, it will be the same concept but slightly different. If you look at the first line, print matrix and zeroth index. So at the zeroth index of matrix is a complete list. So it will output a complete list. Now if I want to find something in that second list, I need to put in a second square bracket and put in the index of the inner list. So if I look at the second statement, matrix 0 0, so first matrix 0 means go into the 0th position of the outer list, that is the first inner list, and then it says 0, that is the first position of the inner list. So this is how it looks, and I can even change the indexes as I want. So from the left, on the left side where I've written outer list, blue colored, the index in the blue circle is the outer list, and as we move towards the right side we go on towards the inner list. In this case we only have 2 lists, so we stop at 2 indexes. In case we had maybe another nested list inside this one, we could also have another index value. And similar is the case with the dictionary of dictionaries. I could have a dictionary. Now each key, instead of having a value, could also have a dictionary in itself. Like the key ls could have a value, but it has a dictionary itself, and that dictionary has different key value pairs. Again, in this one, we could also have multiple levels of nesting. And the elements can be accessed using the same concepts. So in the first line, if you look, I use user data and just do ls. So the value of ls should be the complete dictionary. It outputs the dictionary. Now if I want to print the age of alice, I would say ls, and then there's a dictionary, and I can use a index there. So it says, okay, get me age from here, and then it outputs the age. Same concept if we go from outer to the inner nesting. And let's quickly have a look at this one, where I can just do it for you. For example, we have a list here, this list, and there is another list like this. So the comma, there is another list. Then let's say there is also another list in this one. Like this, and it has maybe two values, 2, 4, 3, 6, 1, 3, 4, and 1. Let me just do it like this. So this list here, um, yeah, so this outer list here, this one will have the index value at the top left side. So if I were to write, let's say the name of the list is matrix, and if I were to access this list, now I say matrix, and I have this square brackets. And now if I say 0 or 1, if I say 0, I will come at this position, and I say 0. Now since this position is a list in itself, I can now use index value here. I can say, okay, this is a list, I can use an index value 1 or 2, and I say now I can use the index value 0 or 1. I say 0, 1, I say 1. Now after this one, I'm at here, okay, and this is also a list in itself. Now it is a list. This is why I can also use another index value. I can say, okay, get me the value of 3, 0. So now I am at this position. But this position is a integer. It is not a list. So I cannot use any more of these index values. And I just have to use 3 index values to get to this. Now if I wanted to get to this 4, what I would do is instead of 0, here I would say 1. So this would become 1, and 0 and 1, this would again become 1, and this would become 0 here. So this is how it goes. Similar is the concept with dictionaries. We can have a quick look at dictionaries too. So let's say we have a dictionary, name it dict, and it's a dictionary. Then we have the first name is, let's say, Alice, and it is also a dictionary. Let's say we only have age for now, and let's say age is 21. We also have other values, we are not concerned about that. This, and then we have another one, let's say Bob. This Bob also has a age, let's say 22, and other values and everything like this. And now we close this outer dictionary over here. Okay, so instead of closing it over here, I will just close it over here like this. So now this dictionary is the outer dictionary, and if I were to access the values, I would say dictionary dot dot, oh sorry, dictionary, and this. So in the dictionary, whenever we have to access a value, we have to write the key. So I say, okay, I want to go to Bob. So I write Bob here. Okay. Now I am here at this position. Okay. So when I write Bob, I can use this value here. Now this value is a dictionary in itself. This is why I can also use another index or key here. And the key I have is age. I can say, okay, age. So now we come here, and this, after this one I am over here, but this one is a integer and not a data structure. This is why I cannot go any further. That will be wrong. So this is how nesting works. Now if I had a dictionary over here, I could use it that, and another dictionary, then I could use that, and so on. So we can keep on going. So let's get back to the lecture. So these are some of the other examples. You can you can also see how these can be useful. So for example, the first one, list of tuples. So let's say you have a list of tuples Alice, Bob, Charlie. So why would you want to have one? For example, the 20 here is a property of Alice. Could be maybe, let's say, age, or we could say mm, anything that doesn't change because tuples do not change. Okay, so let's say it's their favorite number or it's their password or anything like that. Let's say it's their password and the password never changes. So for Alice, the password is 20, and for Bob, the password is 21. For Charlie, the password is 22. But Alice and the password 20 are linked together. I cannot put them in a different data structure. So this is why I put them in one list that holds all the passwords. And then in that list, I keep a tuple of the person and their password. So that makes sense. Now I can access Alice and 20 at the same time. I would know that Alice has this password. It would be less confusing if I stored them in different data structures. Similarly, the next example is dictionary of lists. So here we have grades of different people. So let's say there are three subjects in school and there are three children in a class and we have to give grades. So what I can do is I can use a dictionary and write the name of the person, and in the key I can give a list. So I can say, okay, these are the three marks that the person have gotten in three subjects. Similar to this, I can do it with the other students, Bob and Charlie. So this would like keep the data together, and it would make much more sense for me to keep it like this because marks are connected to people. So if I put them in a different list, that would not make too much sense. Now if I put them in one data structure, that makes much more sense, right? And similar is the case with list of dictionaries. List of dictionaries is mostly like CSV data or column data. We will get into much more detail of this one, but just an overview that this is just kind of like a CSV data or Excel spreadsheet where we have a column where we have like three columns or four columns, and then each row has a value. So if you look closely, the the keys here, for example, name, age, and department could be columns, like the name of the three columns, and then Alice, Bob, and Alice 30 and HR is one row, then Bob 35 and engineering is the second row, and so on. So it is kind of like a CSV or Excel data structure. And this we already saw, but multi-level nesting could be, we could have at any level, we could have nesting. Python doesn't stop us, there is no restriction. But one thing to note is that we should not do too much of this one. Why? We should, I mean, in mostly only one or two levels of nesting would do the job. If you go any further, like five or six levels of nesting, that will only make your code much more complex and difficult to read. So again, not recommended to do too much, but right now, two, three levels of nesting is really good and gets the job done. And similarly, we can also use multiple data structures at different levels. For example, I've used a list, then in the list are different dictionaries, then in the dictionary, one of the value is a list in itself. It could also be tuple and so on. So it doesn't really matter. We can use a combination of these in any way that we feel is better for our task. And finally, what are the advantages of using nested data structures? So first is hierarchical organization. So again, as we've seen, nested data structures allow us to represent complex relationships and hierarchies in data, like something is related to one another. So we can put them in a specific data structure that is nested. So we can like maintain the relation between those, and it also provides us with flexibility, like if we have a multi-dimensional data, we can put it in one data structure. For example, if we have a list of latitude longitudes, now latitude longitude are two values, x and y. If I have four of them, so instead of creating four lists, I can create one outer list, and that list would have four inner lists which have latitude longitude values. So you see, this provides us a lot of flexibility too. So now let's start some coding. First, what I want to do is that I want to open up VS Code, create a new file called module5.py, and now let's get started. So the first thing I want to do is that create a nested list. Nested list is equals to this. Now nested list is just a variable name again. Um, and let's say this and this and this, and in the list I have 1 and 2, 3 and 4, 5 and 6, and so on. I save it, and I can even print it. Run the code. Yeah. So again, it simply prints that. Now, if I want to access the elements again, what I would need to do, let's say I want to access the value 4 over here. So first, I need to reverse this outer loop. So to get to this 4, I need to be able to get to this inner list. So this inner list is at what position? Is at position 1, 0 and 1. So I say 1. Let's just see the output. So now it is at the first position. It says 3 4, this one. Now it is a list. I can traverse this list too. I can use an index too. So if I do this, and I want to do the value of 4, so I say it is at what index of this inner list. Now once we are here, like once we have done this, we are here. We're no longer concerned with the outer list. We are only concerned with this specific list. So the index is about this list, not for the outer list or anything about that. So according to this, the index of 4 is 1. So I say 1, do this, and if I print it out, it says 4. You see, this is how nesting works in lists. I could also try with a dictionary. Nested dict is equals to, let's say we have a dictionary, and in the dictionary we first have, okay, I can also write code like this, like whenever I'm defining a dictionary, the syntax of Python, I could also have it in multiple lines just so it is easier to read. So I could say Alice, as in, now Alice is a person, and the person has these sort of characteristics, as this age, oops, this age 21, let's say last name Alice Doe, and now we have another list that, and now we have another key. Let's name his Bob, do this, and now these are some attributes of Bob. Let's say age of Bob is 32, and let's say last name of Bob is Bob Harley. Let me just comment this out. I want to get back to this one, and as a print, and I say nested dictionary. Now do this. So this is a dictionary, okay? Now using the same concept of dictionaries and this nesting, we can access different values. So let's say I want to access the last name of Bob. So first I want to basically come over here, okay? So what is the first thing we need to do? We need to get to this dictionary over here. So how do I get to this dictionary? I need to use the key Bob. So I say, okay, use the key Bob. Now let's see. And it says, okay, now we are at this level of the data structure. Now it is a dictionary. This is a dictionary here. This thing now returns a dictionary. This is why I can also use another key here. So what key we want to use? We want to use the last name here. Copy this one, paste this one. Now if I run it, the last name is Marley. I can also check the age here. I can do it like this. Age here 32. Yeah, that's perfect. And let's add another thing over here just to make it a bit more complex. So let's say they have a score, they have 3 scores. out of, let's say, 10. 8, 9, 5, score, and we have 5, 7, and 8. So now they have 3 scores. So what I want to do is that I want to look at their second score. So now we are at, yeah, instead of age, I want to say score, because I want to look at the score, like I want to come over here. So what I say, okay, show me the score. Now see, score is a list now, okay? It is not a dictionary, it is not a integer, it is a list now. Now this thing here returns me a dictionary. Now this thing, whenever I write this thing, it will return me a sorry, list. Now if I want to check the second score, this 7, what I need to do? I need to think of this thing is that, okay, now I'm at the list, and now after this one I need to use the index for list. So I will use this. I will not write any value here, because now up till here we are at a list. Now at this point we are at a list, and now if we want to traverse through the list, we want to use indexes. I do this, and you see 7. So this is how you can use multiple data structures in once. So let me just get rid of this. We will come back to this nested dictionary, and we will see like a proper use case for now. But I just want to show you one little use case for this nested list. Like why we have to use this. Let me just bring that at the bottom. So we can also create matrices or metrics like this, this. Now this is a 3 by 2 matrix. We can also have this. Like in mathematics, you have matrices or matrix, and you want to represent the matrix in Python, you can use this data structure nested list. And it is the same as this one. If I just put it over here and put it over here, it's the same. I'm just putting it over here, so it is easier for me to see, and it doesn't matter with Python when I'm declaring these nested structures. Now it is also like easier to see visually, as you would see in mathematics and matrix. So this is how we have nested data structures. Now let's go on and see one more thing about the usage of these ones. So let's say I have a use case question over here. So let's say we have a question. The question says, find me the average of the score of all the um, people in the dictionary. Okay. Let me add one more over here just to make it good. This and this, 2 more people we have. Let's change their score. Let's say 9. Let's say 9. Let's say 7. Let's say 5. And let's give them a different uh, last name. Let's say Hussey. And let's say Carl. And the people, let's say um, John, and let's say Kent. These are the people, and we have their different ages. Let's say 24, let's say 27, and so on. So now what I want to do is that I want to print the average of each person here, like this, average of this, average of this, average of this. Now if I were to do it, how could I do it? Like very basic thing that is not efficient. So first is that I could say, okay, nested dictionary, and now I want to print the average of first person. The first person is who? Alice. I say, okay, Alice. And then within Alice, where do we need to go? We need to go to the score. So I write score. Now score is a list. Okay. So what I do is that I say, okay, print this for me. Okay, print this for me. We are now at the score, and now how I can calculate the average is that I need to sum all three values and then divide it by 3, right? So what I can do is that I say sum is equals to, copy this over here, and then I say this value 8. Now I say okay, add the complete this one, but this time around do this, make it 1, so I'm over here, and do this and copy and paste. So now I'm over here. Okay, so now this thing gives me this value, this thing gives me this value, this thing gives me this value, and now I can divide, like, okay, we have the sum, and I say average is equals to sum divided by 3, and here I say print average. Do this. Now we have average 7.33. Now there is a much better way to do it. Okay, so I say for item in nested dict dot items, and if we just quickly look at the items, like what is that? So I say print item. Okay, item returns us a tuples. But do you think this is a better representation? I think not. I think we should go with keys. Do this. So now we have all the keys. So now we can um, iterate through the dictionary pretty well. Okay, so we do not need to write this thing 4 times for 4 separate people. Okay, so I can say okay, for item, and the first person is um, okay, in fact it should be for nested dict, and here we say item, and if we print now, we're now getting the value of these people. Okay, and now what I'm going to do is that nested dict item, and here I say okay, score, and here I say 0. Okay, but now I can also write this thing here completely like this. I could also write this and just replace this over here like this, like this, and like this. That's fine, but I can even use a second loop over here. I say okay, for I in, now I know that I will be traversing through a list, this list. Okay, now what is that, how do I get to this list? I get to this list over here. So I do it like this, like this. So this thing is now a list. When I write this thing, I am actually over here. Okay, item is, let's say, Alice. So it says item score, get me this gets me over here. So now I'm here. Now how many values there are, like 2, 3, 4, 5, I don't care. If someone has like this, someone has like 5 values, I don't care, because it will iterate through 5 times in a list. So what I say is that okay, for each of the item, add it to a value. So let me get rid of this one for now. And I said total sum is equals to 0. Okay, and I say count is equals to 0. Now the count will keep track of how many values are there, 1, 2, 3, 4, 5, and so on. Okay, so I say sum plus equals to um, I, because I is each item in the dictionary. Now once we have the complete sum, we say average is equals to sum over count. Okay, we missed one thing. We need to update count here too. Count plus equals 1. Okay, or in fact, we could also do like um, this length of what? Length of this thing. You see? This will give me a length of this list over here. So the average is total sum over the number of um, elements that we are totaling. This gives me the average, and now I can say print average is this average. And now let me get rid of this one. Now let's see if it works or if we have some sort of an error. So it says, okay, these are the average. 1, 2, 3, 4 people have 4 averages. Okay, now let's get rid of this one too. So you see how we have used nested loops and this nested data structure, so we can easily calculate operations, we can easily calculate different things, we can perform operations. We can even say, okay, I don't only want the average, I also want the name of the person. So I say, okay, I can print the name of the person. You say, okay, print name. What is the name of the person? How do I access that? I access that using item over here. Okay, so I could say like this, name is equals to this thing, like I'm item over here in this dictionary, and I need to do last name. If I don't need to do last name, I can simply print the item over here, because item is in fact this name over here. So I could do item, then I could say this, and I could get rid of this one because I'm not using this. Now if I do this, they say name Bob, average this, name John, average this. You see how we can use different, like this is a combination of data structure and we can use it to perform different operations. So you can think of it like this is the data that is stored somewhere, and now we can do an average. We can also find the maximum marks that each person has got. We can also find the ages of different person. We can also find the minimum marks of each person. We can also find the overall average of all people, right? Just need to think about this of how you can do it. Now let's say we want to use the break statement over here. So what I want to do is that instead of using a nested loop, I say I have a list. Like, let's do a different question for that one. So this we all understand how this works. So let's just keep it over here for now. So let's say we have a loop, nested loop, or simply let's say list. My list is equals to this. I say 1, 2, 3, 4, 5, 6, 7 and 8. Okay, and 9. So what I want to do is that I want to first get the square values of all even numbers. So I say for I in my list, what I want to do, if I modulus 2 is equals to 0, I want us to print I exponent 2. Okay, everything's fine. And let me get rid of this one, like just the print statement. So in fact, I can just comment this complete code like this. It is now commented. Now we are just concerned with this thing over here. So let's just run it. So it says, okay, 4, 16, 36, 64, that's fine. Okay. Now what I want to do is that I also want to keep the like only the only until the elements remain below 5. So I want to keep on doing this thing only until the value of one of the elements is below 5. Like if it gets over here 6, I do not want to do it. Okay, pretty good, right? So I could say, okay, if I is equals to 6, or we could say if I is greater than 5, what I want to do, okay, what I want to do is that break from the loop. Okay, Now once I break from the loop, I am outside the loop and I say outside the loop just for you to be here. So what it says is once it goes to 6, it should be outside the loop. I run it here. So again it says 41636. So it says okay, do this value, this value, this value. It will do this value because we've written this code above this one. So this is done and then it says okay, it is greater than 5. I do not need to go over here. Okay, I will just break or exit out of the loop. This is how we use different break statements. Okay, you can also use a continue statement, but yeah, just let's just do another use case for this one. Let's say I have this 6, and then I have a 4, then I have a 3, then I have a 2. Now what would happen? Let's see. So again the same output, it exited after this. Even though this value is less than 5, um, it should have been correct according to this expression, but it still exited the loop. Why? Because once it exits the loop, that's it. It cannot go back to the loop again. Okay, that's the point of using this break statement. Now also let's have a look at the continue statement. So let's say I'm always doing a square of the value. It doesn't matter if it is an even number or odd number. Okay, I'm always doing the square of the value. So what I do is that first I print the value. So I say, okay, this is the value in the list, right? And now print the square of the value. That's simple, right? But if the, let's say 6, 7, and 8, let's just see the output for now, and then I'll explain the question. So I print the value, the square, value, square, value, square, value, square, and so on. So let's say I want to say, if the value is 4 or 5, don't print the square. Okay, only if the value is 4 or 5. Don't print the square. But you do not need to exit the loop. Okay, so in that case I will use a continue statement. I say if I is equals to 4 or I is equals to 5, if I has either of these values, just continue. Okay, if I is 4 or I is 5, just continue. What that will do is that it will say okay, continue. I do not need to perform this operation. I will just go back to the top over here and just move on to the next iteration. That is the purpose of continue. Now let's have a look. So it says 1, 1, 2, 4, 3, 9, 4, and 5. It prints 4 and 5, but doesn't print the square of 4 and 5 because continues over here after the statement. Anything after continue is not being executed because it moves on to the next iteration. 6 and 36, and so on. So this is how you use break and continue statement in loops. And that was all in today's lecture. We learned a bit of advanced concepts in this one about nesting and how we can use nesting to hold different data. Why is it necessary to include in a code when using hierarchical data and complex data structures, and we even saw an example of how we actually use the data stored in those complex hierarchies and calculate different um, outputs like we did with the average. So that was all in this lecture, and we will see you in the next one. Up till then, goodbye.